Draw a right triangle in which the side other than the hypotenuse are 4 and 3. Then construct another triangle whose side are 5 by 3 times the corresponding side of the given triangle. Give justification for the construction. So very first thing is, please watch the basic videos before trying out any numericals. Let's look at the scale factor. So here the scale factor is 5 by 3. So what can you tell me about the new triangle and the old triangle? The new triangle is what? Bigger than that of the old triangle. The new triangle is to be constructed along B5 and this is along B3. And this is how you have to relate it. So the new triangle will be bigger than the old triangle. So how do you construct this? First we need to construct a right triangle. So this would be point B. First is let's indicate what is BC. This would be 4 centimeter, and then we have to construct a 90 degree at B. So that would be your 90 degree. So along the length BC, we need to cut an arc which is 3 centimeter away, and that would be point A. And this would give us the right triangle ABC. Then what is the next step? Next thing is to construct a scale that would help us construct the similar triangles. So this scale will have 5 divisions. Reason being, the maximum of the ratio, the numbers in the ratio 5 by 3, right? Maximum of 5 by 3 is 5, right? So this is what we have to do. Next thing is we need to figure out from where we have to draw a line connecting to C, and that would be from B3, because the old line is connected to B3 and connect to C. So B3C, you need to join a line. Next, we need to draw a line which is parallel to B3C. So this, and then parallel to AC, and this would complete the construction, right? So how do you do it practically? So let's have a look at it. First thing is a line which is already drawn, and consider your starting point. So from that point you need to mark 4 centimeter using your compass. So that would be 4. And now on to constructing the 90 degree. How do you construct 90 degree? Draw a semicircle, then with the same measurement draw 2 arcs on the same semicircle, and from those two draw 2 arcs. If you're not able to get this, go to the basics and learn how to draw a 90 degree from there. So one arc, from that arc draw two more arcs, one above the arc, initial arc, and the other on the arc itself. From the second draw another arc. That would give us 90 degree. So extend a line. Next is to mark 3 centimeter along this 90 degree, the new line that is. So this would give us point A. So we have triangle ABC. So this is triangle ABC. Next thing is to draw a similar triangle. For that we need a acute angle. First is the acute angle, and once we have the acute angle, mark 5 units. Why 5 units? 5, we have 5 arcs actually, not 5 units. 5 arcs of equal length, which are equidistant from each other, to the neighbors, that is. Why 5? Because with respect to the numerator denominator, we have 5 as the number which is the highest. So the denominator tells B3 is the one which we have to consider. So B3 from 3, that third arc, connect to C. Right? So that would be CB3. So replicating the angle from B3 onto B5. So that is B3, and from B5 we have that. So copy those 2 points. How do you copy that? Measure them first. So once you measure them, again I'm just being accurate, right? Things are right. So cut your first arc, and joining all of this will give us a line parallel to B3C. I always keep my pencil first and then get the scale so that I don't miss the point. Draw the line at one go. It should not be redrawn. So this would give us parallel lines. So now we found out C dash. Now to replicate the angle at C dash, that is to draw a parallel line. So here you can see I'm taking up a arc which is larger. It's almost covering half of the triangle. So that's okay. Doing that, all that is okay. So marking those 2 points and measure those 2. So we have the required point, and we can see, I just wanted to verify because I was just being cautious. So I'm trying to adjust the scale and check if the lines are parallel. So you can clearly see that they are. So we can just draw. So always verify these parallel lines, because those are the one which kind of, especially the ones which are small, the triangles are small, try to verify and do it. Generally this is where you guys go wrong. So that's your construction of a right triangle, which is similar to on the right triangle of side 3, 4 and 5. Steps of construction. First I spoke about drawing the triangle. So that would be this B, then that would be C, and that would be Y, and that would be X. So along BY, cut BY at 3 centimeter. This will give A. So that would be A. Draw a ray AX making an acute angle with BC on one side of the triangle opposite to that of the vertex. Locate 5 points. So why 5 points? Because we have 5 as the highest number. So B3 to B5, has to be B1 to B5 has to be marked so that the distance between the neighboring points are equidistant. Then join B3C. How did we come to a conclusion about B3? It is determined by the denominator. And draw a line through B5 parallel to B3C to intersect BC at C dash. So that would be C dash. Draw a line through C dash parallel to CA. So this is parallel to this, intersecting the extended line segment at A dash. So that is your steps of construction. Now on to justification. How is that we are able to justify something like this? So first is your same old steps. That's it. There's nothing new. First is we have to talk about the length AC by AC dash being, or BC dash by BC being 5:3. So we have consider triangle BC dash B5 to help us out. So here we have BC3 being parallel to BC dash B5. So this would imply BB3 by B3 B5 to be equal to BC by CC dash, which is equal to 3/2. How did you end up with this? See, the logic is quite simple. We know that if each of this are of length x, so this entire thing is 3x, and this is 2x. So the ratio will be 3:2. Here too we can see that, but it's convenient to show it over there. So we have BC by CC dash to be equal to 3/2, and we are going to take the reciprocal. So this would give us CC dash by BC is equal to 3/2, and then add 1 both the sides. So this will be CC dash by BC plus 1 is equal to 3/2 plus 1. So taking the LCM and all of that, we have BC plus CC dash being equal to BC dash, very clear from the diagram, by BC is equal to, here it is 5/2. Oh, I missed out taking the ratios. I mean inverting it. This is 2/3, and this is 5/3. So we got the required ratio, and all we have to prove is all the sides are of same ratio. How do we do that? We have to prove that the triangles are similar. That's it. So consider triangle ABC and triangle A dash BC dash. So as AC is parallel to A dash C dash, what can we tell? We can tell that triangle ABC is similar to triangle A dash BC dash. Why? By AA similarity criteria. And with this in mind, therefore A dash by B, A dash B by AB will be equal to C dash B by CB. That would be equal to A dash C dash by AC. And this entire thing is equal to 5/3. This is as per first and CPST, corresponding parts of similar triangle. So please remember, this thing is not required, right? That is not to be drawn again. So please see to that you remember to use this and come to this conclusion so that you can decide on how to draw. Steps of construction, try to keep it minimum, and don't forget to label the entire thing. If time does not permit, whatever is important, just label that, and this would be your justification. Please enroll to our program at chalkpieceacademy.com, wherein we'll be teaching you a lot more tricks for faster simplification and calculation, DIY projects. We'll code with Python, we'll work with Arduino Uno. There are a lot more magic tricks and the physics behind it. They're printable materials which will help you recap and understand things better. We'll have live revision and doubt session 2 months before your term exams. It's very cost effective. There would be no ads or any kind of distractions, and we have a dedicated app to help you guys with this.